Hello friends, today we are going to discuss a problem from chapter 9 of C Verma part 1. This is regarding conservation of momentum, and we will also need the principle of motion of a projectile to be able to solve this sum. So let me first define a sum. Here we have a ramp in this shape. The mass of this ramp is capital M. There is a small block of mass small m which is kept on the ramp. This surface on which the ramp is kept is smooth, there is no friction. As well as this particular surface on which the ramp is kept is also smooth. So there is no friction anywhere in the problem. This particular mass is given a velocity v. It is pushed with a velocity v on the ramp. We are supposed to find that after the block travels along the ramp and loses contact from the ramp at this particular point, what will be the maximum height attained by the block. Let me define the problem one more time. The ramp of mass capital M, and there is a small block of mass small m which is kept on it. All the surfaces are smooth, there is no friction. This block is given a velocity v towards right. We are supposed to find what is the maximum height attained by the block as it loses contact with the ramp. So at this particular point, as the block loses contact with the ramp, we are supposed to find the maximum height attained by it from the datum level or from the floor. So this is our problem. Let us try to solve this problem. First we will understand the principle of conservation of linear momentum here. The initial momentum which is given to the system is mass of the block, which is small m, plus velocity of the block, which is v. Initially the ramp is given no velocity, so its momentum is 0. Now consider a situation when the block reaches over here. As the block reaches over here, both the ramp as well as the block are going to move with the same velocity, because this block will push the ramp and they will move together with the same horizontal velocity, and let this velocity be v1. So if you apply, the final momentum will be total mass of block plus ramp together into their combined velocity, which is v1. So what is v1? v1 is the horizontal velocity of block as well as ramp. They will move together towards right. That gives me the value of v1 as m into v upon m plus n. This is the velocity with which both these parts, both these bodies will move together towards right. But please note, as the block comes over here, it has got horizontal velocity as well as vertical velocity. Let the vertical velocity be v2. And that is why, as the block loses contact, it will be a motion of a projectile. The block will move like this before falling down. We are supposed to find the maximum height attained, say h, by the block. So what we will do is, now we will apply the principle of conservation of energy between point 1, which is over here, and point 2, which is the maximum height attained by the block. So let us apply the principle of conservation of energy between points 1 and 2. Let me write this result v1 separately over here. v1 is mv upon capital M plus small m. Now we are ready to apply the principle of conservation of energy between point 1 and point 2. When the block reaches the highest point, there is no vertical velocity. Its vertical velocity becomes 0. So it has only a horizontal velocity, say v1. At the highest point, there is only a horizontal velocity v1. There is no vertical velocity. So at this particular point, the energy of the system is half m into v square. When the block reaches this particular height, its potential energy will be mgh its kinetic energy will be half mv1 square. But please note, the ramp is also moving with a velocity v1. It is moving with a constant velocity to the right because there is no friction. So the energy of the ramp and this stage is also half capital M into v1 square. So by rearranging the terms over here, I am going to get the value of this h. So let us do this. Half mv square equal to mgh. Let me take half v1 square common into small m plus capital M. v1 square I am going to borrow from this particular expression. So half mv square is equal to mgh plus half small m plus capital M, and v1 square is m square v square upon m plus n bracket square. That gives me half mv square equal to mgh plus half 1 m plus m will cancel, m square v square upon m plus n. You can see that small m will cancel, one small m will cancel from all these terms. And you will get v square upon 2 is gh plus half mv square upon n plus n. Let me transfer everything on the other side and keep h on one side. So gh will be v square by 2 minus mv square upon n plus n by 2. That gives me gh is equal to, let me take v square by 2 common, 1 minus m upon n plus n. This is not square, please note, this is 2. So that gives me h as v square upon 2g n plus m minus n is upon n plus n, and that gives me the final formula mv square upon 2g into n plus n. This is the maximum height which is attained by the block after it loses contact with the ramp. Please note that even after the block has lost contact with the ramp continues to move with the same horizontal velocity v1. The small block also has small velocity, horizontal velocity, which is v1, and that is why when we apply conservation of energy at point 2, we must have the energy of the ramp also taken into consideration. So that gives us the final formula or final answer. The maximum height attained by the block is this. Thank you very much.